So now that we learned a little bit, hopefully, about the eyes, now what we're going to do is on 5.3, now you're going to use them to start solving things. Okay, so for 5.3, we are going to solve quadratic equations. Solve quadratic equations with imaginary numbers. Okay, solve quadratic equations with imaginary numbers. So for number 1, I would like you to solve x squared equals negative 13. Solve x squared equals negative 13. So anytime you have a square, what do you have to do to get rid of a square? Root both sides. What do you also have to do anytime you put in a square root? You have to put in the plus or minus, right? So even with i's, even when it's imaginaries, you still have to put in the plus or minus. So x equals plus or minus. Are there any pairs that can come out of here? No, but what do you have to take out of there? The I. So plus or minus, the I goes after that. Okay, plus or minus I, and what's left behind is root 13. That's the answer that I'm looking for. So this is basically the same thing we've always done, but now you're just going to have negatives in there. Okay, but it's still basically the same thing that you've always done as far as solving. Number 2, x squared plus 11 equals 3. X squared plus 11 equals 3. Now, it used to be in our last unit, we wanted to get everything, if it had a square, we wanted everything on one side, and then we wanted to factor and solve. For sure, all of the problems for this unit are not going to be factorable. Okay, so we actually want to put numbers and letters on opposite sides. So to do that, you're going to start by subtracting 11. Okay, when you subtract 11, you're going to have x squared equals negative 8. Then to undo the square, we root both sides. Make sure you put in a plus or minus because we inserted the radical. It didn't come that way. So x equals plus or minus. What does root negative 8 break down to? You know you're going to have an I for sure. And can you break down 8? Yes, that breaks down to be what? 2 and 4. 4 breaks down to 2 and 2. Okay, so we're going to be able to take out a pair of 2's, leave a 2 behind. So we always put the number in front of the I, and then anything that's left behind still stays in the radical. So answer I'm looking for is plus or minus 2I root 2. Questions on how I did that? Not too bad, hopefully. Okay, how about number 3? Try 3x squared equals negative 81. 3x squared equals negative 81. Something's attached by multiplication. How do you undo that? Divide. So divide both sides by 3. You divide by 3. That gives you x squared equals, what's negative 81 divided by 3? Negative 27. Then to undo a square, root both sides. So we're going to get x equals, as soon as you put in the radical, make sure you put in a plus or minus for your next step. Obviously, we're going to be able to take out an I. What else breaks down out of 27? That should break down to 3 radical 3. Okay, so since we also had a negative, it's going to be 3I root 3 for your answer. Questions so far? Okay, we'll do one more of this type and then we're going to move on to a little bit different type of problem. Okay, let's try 2x squared plus 18 equals negative 72. 2x squared plus 18 equals negative 72. Where would I start? Any ideas? Start by moving the 18, right? So subtract 18. Since we have the same sign, you're actually adding those. So 2x squared equals still negative. 72 and 18 gives you 90. Then divide both sides by 2. That leaves you with x squared equals 90 divided by 2 is negative 45. To undo a square, root both sides. And if you radical both sides, we get x equals still plus or minus. What can be taken out of a negative root 45? Do you guys need me to keep showing you the factor trees, or that breaks down to 5 and 9. 9 breaks down to 3 and 3. So we're going to be able to take out a 3, an I, and leave behind a root 5. That's the answer we're looking for. There you go. Anyone have questions on how we do any of those? Okay, now we're going to look at something that's a little bit more complicated. Okay? Now we're going to look at ones that are, like I said, just a little bit more complicated. Okay, so something like this. We're still solving. Okay, if you have, sorry, kind of sideways. Something like, let's try in parentheses x squared plus 5x minus 1 squared. So the whole parentheses squared equals 25. Whole parentheses squared. There's kind of two different ways you can do this, okay? The first one is we could use those Q's. Do you guys remember the Q's from the quantity factoring? Okay, when you solve. Would you prefer to use the Q's, or do you want to just leave them like this? Just leave them? Okay, that's fine. So how would you undo the square? Root both sides. If you root both sides, what's the next step you have to put in? The plus or minus. Okay, so that means you're going to get this whole thing, x squared plus 5x minus 1 equals plus or minus, what's the square root of 25? 5. Now, in order to do this, since you have two answers here actually, the plus and the minus 5, you actually have to break this up into two problems. Okay, we're going to set this whole thing, x squared plus 5x minus 1 equal to positive 5, and then do another problem, x squared plus 5x minus 1 equal to a negative 5. Now, these for sure, okay, these are set up intentionally so that they are factorable. Okay, so since these are factorable, we have to move everything to one side. So we're going to start by subtracting 5. So we'll just do this first one, the one on the left first. So that gives us x squared plus 5x minus 6 equals 0. You do have to factor this, so it's just like what we did in Unit 7. Okay, so just like what we just completed. Okay, what would multiply to negative 6? Add to positive 5. Well, it multiplies to negative 6 and adds to positive 5. What are your signs going to be? Both plus, both minus, or one of each? One of each. What multiplies to 6 adds to 5. 1 and 6, so the 6 is positive because the larger number goes to the middle sign, which is positive. That's the 1. Then what do you think we do? Now, just like our last unit, set each part equal to 0. So we're actually going to get x equals negative 6, x equals positive 1. And I did that because I did the inverse operation, so you can write these out and show the work if you need to. Okay, I don't expect that a lot of you are going to show that portion. That's fine. Then you have to do the other side. Okay, most of these will have 4 answers, for sure. Okay, so that's 2 of the answers. Here, we're going to do the same thing. Add 5 to both sides. We add 5, that leaves you with x squared plus 5x. Negative 1, positive 5 gives you plus 4 equals 0. Factor again. What are your signs going to be? Both plus, both minus, or one of each? Both plus. If it's plus at the end, they're both the same as the middle. Then what multiplies to 4 adds 5? 1 and 4. And then same thing, we want to split these up. and set each part equal to 0. So here you actually have 4 different answers. Okay? -6, +1, -1, and -4. Okay, so you can get up to 4 different answers here. You're fine. Just make sure you watch these. Yes? No, because -1 is different than +1. If you wanted to simplify this, you could write -6, -4, and then plus and minus 1. If you wanted to be even more simple. This is a +1, not a negative. Yeah? Good. Okay, let's try, I have 2 more different types that we're going to do. Okay, number, what are we on, 6? I'm combining 2 sets of notes. So, number 6, let's try, in parentheses, x plus √2 squared equals 8. X plus √2 squared equals 8. X plus √2 squared equals 8. Any ideas? How would I start this? Take the square root. So root both sides. Remember to put in a plus or minus. So that gives you x plus √2 equals plus or minus, what's the square root of 8? 2 √2. Okay, you got that because 8 breaks down to 4 and 2. 4 breaks down to 2 and 2. So you can take out a pair of 2's and 1's left behind. Then, since this is plus and minus, you have to set up 2 different equations. One with the positive, one with the negative. So x plus √2 equals the positive 2 √2. And you can write the plus sign in front if you want to. And x plus √2 equals a negative √2. Negative 2 √2, sorry. I almost forgot a number. Then, to get x by itself, we're going to subtract the √2 on this side. So that leaves us with x equals, what's the coefficient in front of this? What's the number in front right there? This is like a 1. So what's 2 √2 minus 1 √2? 1 √2. Okay? You do not cancel these out. It's kind of like 2x minus 1x. Okay, so that's one of your answers. Here, we're going to do the same thing. You want to subtract the √2 from both sides. Remember that coefficient there, the number in front is a 1. So that's going to leave you with x equals, what's negative 2 √2 minus 1 √2? Negative 3 √2. And those are your 2 answers. Now, technically, if you wanted to, you could plug these back in to check your answers, but you don't have to. Okay, but it is possible to check your answers. Okay, I'm going to do one more and then we'll be done. For number 7, I'd like you to solve, in parentheses, √7x. The √7 is underneath the radical, the x is not. So √7 times x plus 2 squared equals 25. √7 times x plus 2 quantity squared, so that means all those things in parentheses squared, equals 25. You will have one on your test that's pretty similar to this. Where would we start? Any ideas? Where would we start this one? How do you undo a square? Root both sides. Okay, put in your plus or minus. That leaves you √7 times x plus 2 equals, plus or minus the square root of 25 is 5. Then split this into 2 problems. So √7 times x plus 2 equals positive 5. And √7 times x plus 2 equals negative 5. For the side, the one on the left, what would you do to solve? Ideas? Start by subtracting the 2. Okay, we want to get numbers and letters on opposite sides here. So root 7 times x equals 5 minus 2 is 3. How is the root 7 attached to the x right now? By add, subtract, multiply, or divide. By multiplication, so to get rid of it, you divide it away. So divide by root 7. Are you done though? What is wrong with that answer? Can't have a root on the bottom. So to rationalize it, what do you have to multiply the top and bottom by? By the root 7. Okay, so that's why this one is obviously a little bit more difficult, because you have to rationalize. So that would give you 3 root 7 over a whole 7. You're half done. That's one answer. Then you're going to follow the same procedure on the second one. So start by subtracting 2. Leaves us with root 7 times x equals negative 2 minus 5 gives you negative 7. To get x by itself, divide away the root 7. So divide both sides by root 7. Leaves you with x equals negative 7 over the square root of 7. Then to rationalize that, you multiply it away. So multiply by root 7 on both the numerator and denominator. So you'll end up with an answer of x equals negative 7 root 7 over 7. So I'm sorry, I lied. That's not done yet. What can you do now? Reduce. Okay? This whole 7 and the one on the bottom, reduce. So that actually equals just negative root 7. If you put the 1 in front, that's fine, but you don't have to. Okay, so 2 different answers there. That is basically as hard as this lesson's going to get. Okay, so for homework for this, you're going to be working on worksheet 3. You're doing numbers 1 through 15 on, as well as in your book, page 279. 279, you're doing numbers 3 through 11. Okay, 3 through 11. And we'll make this one odds as well. Okay, so you can do odds for both. Yes. I will put up the book assignment if you'd like it. You can take a picture of it, or you can obviously work on it at home. Okay, but if you don't know where your book is, or you don't want to look up your book, or look in your book, excuse me, you can take a picture of the assignment. Okay, that's it.